right, let's start with going over the homework last night. It was page 11. I think most of it should have been pretty straightforward from the notes that we did yesterday or using your reference table. The first one, rocks are classified as sedimentary, igneous, or metamorphic based primarily on what makes them igneous, sedimentary, or metamorphic. Yeah, why don't you guys show me with your fingers? Yeah. Okay, you got it. Method of formation. Also, the Regents likes to call that the origin, so how they formed. This one is not a real Regents question. Regents doesn't usually do which ones are not true. That is the only time they're not jerk faces. They don't do that. But this question is which one's not true. So in other words, 3 of them are going to be right. Which is the one that was wrong? Oh, I'm seeing a couple different answers. I'm seeing 2, 3, and 4 as a choice. So let's go through all 4 answers real quick just to see. So again, we're looking for the one that's not true. So number 1, nobody picked this. So my guess is you guys know this one is true, but let's double check. Sedimentation is a process that leads to sedimentary rocks. That is absolutely true. So it's not that one. Number 2, when heat is applied to a rock and it melts, it may form a metamorphic rock. So we have melting. Does melting form a metamorphic rock? No, metamorphic rock forms magma, which solidifies into an igneous rock. Does melting ever make a metamorphic rock? None of these say melting makes a metamorphic rock. So that's actually the one that's false, which makes it true. If it just said when heat is applied to a rock without the and it melts part, then it would have been true. So it was that melting part that made it wrong. And notice how they had that like second. They just used the heat part first. And a lot of you saw heat and you know that heat and or pressure will form a metamorphic rock, but they use the word melting. As soon as melting gets in there, it's automatically an igneous rock. The other 2 are true. A sedimentary rock in the future may turn into another rock. Yeah, it could melt into magma, it could get heat and pressure, or it can weather and erode into new sediments and turn back into a new sedimentary rock. So that's true. And solidification is always needed to form an igneous rock. There is no other way to get to igneous rock without going through the solidification path. So those other ones all were true except for number 2 because they threw in the word melting. I'm not sure with question 3 we really emphasize this yet. We'll really talk about it next week when we go deeper into sedimentary rocks. But where does the burial process, where do you think it happens? Go ahead and show me what answer you did pick. All right. A lot of you, they're not going to be buried deep. Sedimentary rocks happen at the surface. If you got that one wrong, don't stress because I technically didn't teach it to you. I will teach it to you Tuesday. Number 4, though, you should be able to get this one. The solidification of magma produces which answer? Yeah, nobody's got that one wrong. Only igneous rocks. Solidification of magma, that is only going to be an igneous thing. And number 5, again, this one's looking for which one is not supported by the rock cycle. Which one did you guys pick is not true again? IMC, okay, another couple. It's these not ones that confuse you guys. So let's go through. Which one is false is really what we're looking for. So is number 1 false? A metamorphic rock may become sediments. Can a metamorphic rock become sediments? Yeah, weathering and erosion makes sediments. So that one is true. So that is not the right answer. Number 2, metamorphic rocks may one day undergo melting. Can metamorphic at some point go through melt? Yeah, it can melt. It doesn't mean it did melt. It means it can in the future melt. So yeah, that is true. Has a metamorphic rock undergone sedimentation? Is sedimentation a process to make a metamorphic rock? Nope, that's the false one. Sedimentation makes a sedimentary rock, not a metamorphic. This is the one that's false. because a sedimentary rock should go. And then finally, a metamorphic rock may eventually become another type of metamorphic rock. Yes, a metamorphic rock, one of the things that could happen to it is it could get more heat and pressure and turn into another metamorphic. That one is true. Oh, so 3 was the right answer there. None of this will be on the quiz. None of this will be on the quiz tomorrow. Tomorrow's quiz is only on mineral stuff. So pages 1 through 9, I think. Yep. Pages 1 through 9 are fair game for tomorrow's quiz. It's 14 old Regents questions. I believe it's 13 multiple choice and 1 short answer. You will need to answer using your reference table, but make sure you know definitions. Like everything we did here, make sure you know what luster is. Make sure you know what hardness is, how you test it. If you've been doing okay in lab, I'm sure you'll be okay on the mineral quiz tomorrow, but I would definitely review what those mean. Any questions about minerals?
How long is the test?
I think the test or the quiz would take about 15-ish minutes. And then, then I have some igneous rock questions for you. All right. So speaking of igneous rocks, yesterday we did page 13 and we learned that even though all igneous rocks come from melting into magma that solidifies into igneous rocks. So we know they all come from melting and solidification. We learned there's 2 types, intrusive and extrusive. We emphasized that intrusive, they happen on the inside. Because the other inside, they cool slowly. Because they cool slowly, they have large crystals. The opposite is true about extrusive. They form on the surface. They cool very fast, and because they cool fast, they either have teeny tiny crystals or no crystals at all. If you grab page 6 of your reference table again, now we're going to look at the bottom half of this chart. There's a lot going on this chart. This is, even though it looks weird, this is another dichotomous key. This is another game of guess who, really. And we are going to use the properties of igneous rocks to be able to narrow it down, just like you use the properties of all those guys or all those characters, I should say, on the guess who board to narrow it down the other day to figure out I had Bill. We're going to do the same thing to figure out what igneous rocks you might be talking about. And again, in lab, you're going to get, I think, only 6 igneous rocks, not 10 like you are for minerals. And you're going to be told, okay, name that rock. So just like we have been for minerals, we're going to switch it up to igneous rocks now. There's a lot of stuff on this chart. You'll notice that it's almost like it's 3 sections large. You got the top, the middle, and the bottom. There is a lot of stuff here. And remember how yesterday we were taking notes up around the chart? I really want to do that again, except for there's not enough space to write here. So if you notice on page 15 of your packet, you've got a squished down version. So I know this is a little blurry. So if you are having trouble seeing something on this chart, it is this exact chart from your reference table. But now we're going to go through, we're going to take some notes on this stuff. Take a minute to look around page 6. Are any of those words on there already sound familiar? Like which one?
Granite.
Oh, so you know the names of some igneous rocks. So you know that granite, which we actually talked about yesterday, granite, basalt, pumice, and what other one did we talk about yesterday? Oh, yes, obsidian. Those are names of igneous rocks. In fact, I want to add that to the chart. So if you have a highlighter, this would probably be best. Yeah, hang on. Let's do one thing at a time. So what I would like you to do, does anybody want me to deliver them a highlighter? highlight the names of the rocks. So you're just highlighting those inside boxes at the top half there. These are the names of the rocks. I'm going to write over it. So because I just wrote over it, you might not be able to use this one to identify rocks, which is also why we're not doing it on our actual reference table. So we're highlighting and covering up the names here on the one in your packet. It's not like the or the mineral chart where they were at the final destination at the end. This one's weird. They put the names of the rocks in the middle. Now, Logan, you were mentioning something else sounded familiar from yesterday. Which ones? Intrusive and extrusive. So just like metallic and non-metallic was the first question you asked on the mineral chart, intrusive and extrusive are going to be the first questions we ask about on the igneous rock chart. So you'll notice that I have bubbles that point to each one. So this upper right hand, nope, that's the left, sorry. We're just going to label that that's pointing to the extrusive box. And again, it is going right to the extrusive box. And I just want you to put a reminder here that they cooled quickly on the Earth's surface. I think it's easy enough to remember extrusive, exit, exterior. But if you do need a reminder, you might notice the word right here underneath the word extrusive. If you can't read it on that chart, look at your actual reference table, and it says they're volcanic. I use that as a hint. When you guys picture a volcano, what do you picture? Lava. And how's it kind of look? So when I picture a volcano, I kind of picture a mountain with lava spewing all the way out of it. Exiting, that's where I'm going with this. So volcanoes allow the igneous rocks to exit. So that's my hint. That is a reminder that those are extrusive igneous rocks. They're also called volcanic. The other bubble, this one in the middle on the left, that's pointing to the intrusive. And underneath that word, in parentheses, they have the word plutonic. Which I believe is Latin for inside. Let me just double check that. Plutonic. It is, so Pluto is the god of the underworld. So that's why those are called plutonic. So if you know, I don't know if that's Greek or Roman or whatever, but whoever named Pluto, he was the underworld god. So that's why these are called plutonic, because they're inside the Earth's surface. So in this one, you just want to remind yourself that they cool slowly beneath the Earth's surface. Now the next thing over, so we do intrusive, extrusive. The next thing is crystal size. We have a few choices for crystal size. What does this box, which says non-crystalline, what do you think non-crystalline means? No crystals. Then it says less than 1 millimeter, 1 to 10 millimeters, and greater than 10 millimeters. Do you guys know how big a millimeter is? Really small. So small. So here's a ruler. This is a centimeter. From this line to this line is 1 centimeter. There are 10 millimeters in that. So each of these little lines is a millimeter. I like to kind of point out that a millimeter is about the size of the tip of your pen or pencil. So that's a millimeter. So if you see crystals less than that, they're going to be really, really, really tiny. Then the next choice is 1 to 10. So 1 is again the tip of your pen. 10 is about how fat your pinky is. I know it's not quite, some of us have bigger or smaller pinkies, but it's close enough. So 1 to 10 is between your tip of your pen and your pinky. Just to point out that that's still pretty small. Now I have just like an average ring here. None of my crystals are bigger than my pinky. So if you see something that has a crystal bigger than your pinky, even if you're not like interested in rocks, you're going to be like kind of impressed. That's going to be a pretty big crystal if it's bigger than somebody's pinky. What we want to put here in the notes for crystal size is just a reminder that the longer the time of cooling, the larger the crystals. So the longer the cooling time, the larger the crystals. Then they go ahead and they give those crystal sizes a name. And stupidly, they call it texture. When you hear texture in your everyday language, what are you thinking about? How it feels. So you might be like, oh, the desk is smooth. You might think this rock is rough. You might think your sweatshirt is soft. Yeah, that's great because that's common sense, but earth science very rarely has common sense. Now crystal size is going to be now texture is going to be how big the crystals are. See how each one matches up with the crystal size? So glassy matches up with non-crystalline. Fine is that 1 to 10. Fine is less than 1. Coarse is 1 to 10. And very coarse is the larger than 10. So in this box, we just want to emphasize that. So texture equals crystal size. Crystal size. And what I mean is, I'm going to write all 4 of them. Glassy, fine, coarse, and very coarse. So glassy equals no crystals. Fine is less than 1 millimeter. Coarse is 1 to 10 millimeters. And very coarse is greater than. And if you want to use the greater than or less than symbols, that's fine, as long as you do them correctly. So again, texture doesn't mean how it feels. It's more like talking about how it looks. Continuing on with that, there is another box for texture. So texture continued. And here our choices are non-vesicular and vesicular. Underneath the word vesicular, do you see a parentheses? And what does it say? Vesicular equals gas pockets. So these gas pockets or holes, you get a rock and it's full of holes. Here's an example. Oh, you can't see the holes. I might have to I'll just pass these around. But you can see actually what looked like black spots on these from on the camera here. Those are actually holes. These holes happen when they cool so fast, the air gets trapped. I like to relate this to, have you ever had a pizza crust that has a big air pocket in it? Okay, some people like they're my favorite, to be honest. And I can see from your faces that some of you don't like those air pockets. That's the same kind of thing. What happens is air got trapped in the dough while it was cooking and it kind of solidified around the air bubble. In this case, instead of cooking, it was cooling, but the same thing happened. When that volcano over here was exploding, some of this lava cooled instantly, leaving air pockets inside the rocks. Okay, I see that I'm losing you guys, so we only have a couple more to go here. These are much quicker. That's the entire top half. They then take it another step further, and we've got this middle section that says color, density, and composition. This part is so easy. See how color, density, and composition are listed down the middle. If you are to the right of that, any of these rocks that are to the right of the word color, they will be darker, they will have a higher density, and they're going to be what's called mafic. Versus on the right side, so like granite and pegmatite, they're on the left, they're going to have a lighter color, they're going to have a lower density, and they're going to be what's called felsic. So right here, we're just going to add these three, which says color on the right equals dark, on the left equals light. Density, right equals higher, left equals lower. And then composition, I'll tell you what those mean once you're ready. So with that composition, you'll see on the reference table underneath the word mafic, it says it's rich in Fe and Mg. And underneath the word felsic, it says rich in Al and Si. It just means the rocks that are on the right have a lot of iron and magnesium, where the rocks on the left, they have a lot of aluminum and silicon. That's all they want to know. And there's only one section left. It's this box right here. Do any of these words look familiar? They should. What are those? Those are the minerals. So we've got quartz, potassium feldspar, amphibole, plagioclase feldspar. Those are minerals. How it works. Notice that each rock up here has a box. For example, granite. If you see one of the symbols underneath any part of that box, like the polka dots, the other polka dots, the stripes, the black, or the other lines, even if the words, like right here, biotite is not underneath the word granite, but because that black splotch is there, if any of those symbols show up underneath the rock, it is going to be the minerals that are inside that rock. So for that set of notes, minerals listed below the rocks are the minerals that make up that rock. So using this reference table is going to be a lot like using the mineral chart and a lot like playing Guess Who. So do you guys still have your Post-it notes or does anybody need some delivery? Need some delivery? You're going to want to have at least 2 Post-it notes. Even with 2, you still might need some spare Post-it notes. Anybody else? Anybody else now? So again, once you have these Post-it notes, go ahead and just keep them stuck inside your reference table as for as long as you can. I know they won't stay forever, but they really help narrow down your choices when doing an activity like this. So I would like to ask you to, let's find a mineral, or I'm sorry, not a mineral, a rock. So we're going to start with the rock is going to be extrusive. What do we want to use our Post-it notes to cover up? We're going to take our Post-it notes and cover up all the intrusive igneous rocks. So just like the minerals, they all have their own boxes. So you can see extrusive has a box here, intrusive has a box. Anything that lines up with those boxes, we want to get rid of. So you should have left obsidian, pumice, vesicular rhyolite, andesite, vesicular andesite, basalt, scoria, vesicular basalt, and then half of the diabase. So the rock I wanted was extrusive, so it's one of those. Now I'm going to tell you that that extrusive rock is also glassy. What do I need to do now? Get rid of the fine. So if I move my Post-it notes up to cover up that fine box, now we're left with only 4 choices. This rock could be obsidian, basaltic glass, pumice, or scoria. Now I'm going to tell you that the rock I am looking for is vesicular. Cover up the non, and this is where I just saw a couple of you bring in your pen. So if you bring in your pen, notice we have vesicular and non-vesicular up here. I said my rock was vesicular. So I want to cover up the non-vesicular one. So that leaves the only 2 my rock could be is pumice and scoria. Now I'm going to tell you my rock is darker in color. How do we deal with that situation?
Go under.
Yeah, so you might have to move your sticky note to peek underneath. I said my rock is darker in color. So it's which side of the chart is it on? Yep, so it's to the right of the word color. So the rock I want, scoria. That's actually this one right here, which I'll pass around for you to investigate a little bit if you're interested. So while you're looking at scoria, that's vesicular. It is glassy. Ooh, which one of you should I call him? Riley, would you have ever said that rock is glassy? No. So I should have talked about that when can I borrow it again? I should have talked about that when we looked at texture. What does the word glassy mean again? It means no crystals. So unfortunately, we have to get the word glassy, like looks like glass, out of our brain. When you look at this, I want you to also look, there are 0 crystals in this. Nothing that looks like a piece of glitter, nothing shiny at all. This is non-vesicular, this is non-crystalline, which means it's glassy. This one, which is obsidian, this one is also glassy, but this one looks like glass, so that one's a little bit easier. So I do need you guys to think of glassy as no crystals, not glassy as looks like glass. All right, so take a look at those rocks. I just want to tell you what you're going to be doing tomorrow while I'm gone. So again, you're going to have that 14-question quiz. And then after that, I'm going to assign you page 17 and 18. Page 17 is 18 are just legit questions right off the reference table. You'll use your reference table and some post-it notes to go through questions 1 through 22 tomorrow. I will say you guys have about 8 minutes now, that if you wanted to get a head start on it, you're welcome to. Because I do think you might end up with about 5 minutes of homework tomorrow, depending on how fast you work. It is due, this pages 17 and 18 are due on Monday. Okay, so however you want to do that, pages 17 and 18 are due on Monday.